Hey Rick, how are you doing?
Hey, how are you?
Pretty good. All right, let's see. Share. Okay. All right, let's start with questions. Any question related to Module 3? And I guess today we'll be starting Module 4. Any questions related to that?
No questions.
All right, let's check out Module 4. Module 4 data visualization tools. Okay, so we looked at it a little bit. It's mostly going to be about matplotlib and all that. And then we'll have the final one, machine learning model for module number 5. So we still have a couple of different algorithms that we need to cover, but we have time to cover that. So today, what I want to do is I talked about yesterday we did something a little bit different, which is using Flask server in Python. So what I want to do, not Flask, but I want to do image classification. And again, this can be a real world scenario. You may have multiple images of things that you want to classify. So we're going to build a classification model that can classify images between cats and dogs. Let me go ahead and give you this URL. There are many different kinds of data sets that are available. This one is a little bit, it's only 68 megabytes, but it does have a lot of different images. Let's go ahead and try to see what those images are. I think I already have downloaded. So I have a train folder, and it has cat folder and dog folder. And for cats, obviously all the images are cats. And for dogs, all the images are for dogs. So somebody has already done like, you know, the organization of cats and dogs into two different folders, which is cats and dogs. And now is our job is to use these images to train a machine learning model that can predict when you give that particular model a cat, the classification model can say cat or dog. So how do we do that? So let me go ahead and start with creating a new notebook. And there are many algorithms you can use to do that. I think we're just going to go with logistic regression because it is a classification problem. We're classifying between cats or dogs. But the same thing can be done for fruits. Like maybe you have different fruits. You have like, oranges and mangoes and apple and pear and all that. So the same logic can be applied to do any kind of a classification of images. So that's kind of good that once we learn this, you can actually classify images. So the first thing we need to do is to read these images. Right now, they are in a folder called train. And inside the folder called train, we have, so over here, we have a train folder. And inside the train folder, we have cats and dogs. So main folder is train folder. So we need to somehow read the images, resize them, maybe flatten them out into an array, and then add it as X and Y. So in order to read something from a file, you will have to import OS. And OS is already available to you, so you don't really have to do anything else. You can just import OS. And now we can go ahead, try to loop through the array or loop through and get the items. So for category in cats and dogs. So this is the array that we're going to go through. The array contains only two items, cats and dogs. But now what we want to do is we want to get the file name. So in order to get the file name, you can use imRead function, but this function may not exist right now, so we'll see. OS, well, let's see what is os.path. os.path dot join, and we have to make sure that we get the correct path because our images are inside the training folder. So I'll say train slash whatever the category is. It can be cats or dogs. And actually we shouldn't be writing this right now over here. We have to first go into the directory itself. So for file name in os.list directory, training directory, and then go into the category like this. Now, if I go ahead and print out file name, I should be able to see all the files. Let's make sure we close it. There we go. So we are able to access all the different files in the cats directory. And if we scroll down at the bottom, in the dogs directory. So we got all the files, meaning we can access it at least. Now what we want to do is we want to read these files and as an image. So one of the functions that you can use to read these files is called imRead, but we may have to import something to get it to work. So if I say imRead, and I will have to get the correct path, join training folder, again, category, file name. So that's a path. That's the whole path of that particular file. And we will read as a gray. We're not going to read as color. We're going to read as gray. And the reason that we are reading as a gray image instead, or black and white image, in other words, is because we will have to only deal with the intensity of the color rather than different attributes like RGB, red, green, blue. So that's why. So we will have less things to work with. Now, if I try to run this, it might say, you can see that saying imRead is not defined. Let's go ahead and see if we can actually import imRead, SKI, but I don't think we have SKI image. Let's see, import imRead. So it says no module SKI image is found. Okay, so not found. So let's go and we will have to make sure, because our Jupyter notebook only contains pandas, it contains NumPy probably, scikit-learn, matplotlib. It does not contain this thing like SKI image. So let's see how to import SKI image. So to import scikit image, okay, so scikit, all right. So in order to do that, we will have to go to our terminal. Let's stop it. And then we will say conda install scikit image. And scikit image is coming from the scikit machine learning library. It helps to read the image and all that stuff. So now we're installing scikit image into our Jupyter environment. And now we're going to run it again, Jupyter Notebook. Okay, there we go. Probably we have to refresh it. Okay, not sure what happened to our code. I think it kind of messed up a little bit. Let's see what happened. Okay, Now we can try to import from ski image.io import im read. Let's see if that is, now it's not no longer complaining, so that's good. Let's fill this out. So im read, meaning reading the image, the path to the image will be based on the category. So let's pass category over here. And like this probably, and then file name as gray true. This is going to read us the image. We're going to put the image into img right there. So this is going to allow us to at least get the image. We can also resize the image. I mean, these images, it's a good idea to resize the images into something that is common for all the images. So we can say resize image into 64 by 64. And there is no resize function, so we'll have to make sure that we import it. So skimage dot transform import resize. Okay, so we got the resize image. That's good. And now we can actually try to find out that we can somehow convert this image into an array. So if I simply print out this image, I'm sure if it's running correctly or not. Run selected cells. Okay, I'm not sure what's going on, but let me save it first. Cats, dog, classification. Let's refresh it. Let's try to find out our thing that we just did. And try to run it. Think that anything is running in this case. Oh, did we? Yeah, we did run Jupyter Notebook. That is running. Some sort of errors is throwing over here. Kernel does not exist. Something, but right now it's running. Doesn't look like it's doing anything right now. Let's see. Yeah, it's running. It says it's running. Let's see what's going on. Run all cells. Should be able to run this loop and give us this image, or just print out the image. Saving files. Not sure why saving it to untitled. Well, let's see what's going on. Okay, let's see if this works. Okay, not sure what was going on, but you can see over here, it's printing out the image over here. It's basically an array. It might be like a multi-dimension array. So you can see it's printing it out. Yeah, it's definitely a multi-dimension array. So what we want to do is we can flatten it out. That will help with testing it if we have just one array, not like 2, 3 dimensions. And one of those functions to flatten it is called image.flatten. And that can become our x-axis. So we can go over here and create our x array as well as the y array. So x will be our independent variables and y will be the dependent variable. And whenever we flatten it out, we can just append it to that. And for y, it will simply be the categories because y is the actual classification part. So those will be cats or dogs, and that's it. You can say singular, I guess, cats and dogs, but I'm just using the same folder names. And that is going to at least give us X and Y, and they will have some information regarding the cat itself, or I mean the cat or the dog. So if I say X of 0, probably have to say print maybe. Yes, kind of getting really slow. I'm not sure what's going on. Maybe it's still executing this page. Oh, maybe I didn't run this. Oh, yeah. Let's see. Yes, taking too much time to run. File change has changed on this, and the last time it was open. I don't think it has changed. Maybe it is open somewhere else also. Mm-hmm. Okay. Super slow. I don't know what's going on. Let's close this, close this, close that. All right, let's do it again. Here we go. And run all cells. I have no idea what's going on, but nothing is really working. Yeah, it's just dead. Connecting to kernel. Something is weird. Okay, let's disconnect that again. Let me just completely, let's see. Yeah, let me just completely kill Safari. And do it again. And we have cats and dogs classification. Let's try to run all of them. I have no idea what's going on over here. What is that? Shouldn't be that long. I mean, should be pretty quick.
I'm trying it on my end to see if it does the same thing.
Hmm. Okay, let me try to run it on, yeah, the same thing. Did I mess up somewhere? Resizing the image. Mm, let's see. X is equals to 0. I mean, empty. Okay, I guess it did. It just took forever, but it did run. So you can see over here on the print x0, it's basically giving you, this is a kind of like a flat representation. You can see it's a flat array. It's no longer an array inside an array. And if I print out y of 0, that is going to give me the classification. It just take a while to run for some reason. But if we run this all cells again, then we will find out that X classification, or X is simply an array of some numbers because we have converted it when we are doing X dot append, and Y dot append is simply the category. So it will be cat or dog. That's it. All right, so we'll see. I don't know what's going on over here. It's just doing very slow. The next thing is we need to do the learning part of it. So we'll say from sklearn dot model selection. So this is where we have already done it multiple times. We'll say train, test, split. Always a good idea to split things. And then xtrain, and then xtest, y train, y test, train, test, split. We can pass in x and y. Test size 0.2. Yeah, it is working. It's just super slow. All right, there we go. So 0.2 is the test size. There we go. And now it's time for training. So from sklearn dot linear model, import logistic regression. And then we can actually create an instance of logistic regression. Logistic regression. And then to train, we'll use fit x train, y train. And the training part already, you can see it messes up because I guess we have a lot of images, even though they're not like super huge, but it's basically saying that you need to increase the number of iterations, which we also found when we were doing something related with handwritten images or handwritten letters. So for the logistic X regression, we can pass in different iteration, maximum iteration. We can say 8,000 or something. Let's train it again. Okay, now at least it was able to train. Let's, once we have done training, let's check out the score. So score, we should always be passing based on the X test and Y test, because these are the things that the algorithm has not really seen. Wow, this is a pretty bad score. The last time I was doing it was like 99%. So I'm not sure, or maybe not. Maybe I was doing it a little bit wrong. Yeah. So if I do a score, and this is the correct one, X test, Y test, 52%, pretty bad. If I do, which I shouldn't, if I do score on X train and Y train, that's 99%. So first of all, the first question is that why this is 99%, and if I pass in X test and Y test, why is that 52%? So what do you think, Rick? Why is this discrepancy in the score? X
Uh,
test. See that?
my apologies. Can you I was trying to replicate what was going on and I got
Mhm.
distracted. I won't lie. I was trying
Sure.
to see if there was a delay in mine, and there is a delay. It's just it's taken a
Mhm.
long time. Can
Yeah.
you repeat what
So,
you
so my question is, when we look at the score, The first one is 99%, but the second one is 52%. So what is going on and why is the score different? Or why is this 99%?
Um, hmm. I don't know. I know it'll have um I guess because that's what it's trained on, or that
Yep.
it's
Yeah, that's the answer. Yeah, that's what it's trained on. So it already knows the stuff. It's kind of like if somebody is preparing for exam and they just, train on 100 questions and when you're testing it, those you give one of those 100 questions, well, they will already know that stuff. And so we should never even look at the score for training because that's not real life. I mean, in reality, we should be looking at tests. So on tests, it's actually pretty bad. It's like 52%. So it's not that great. So if half time it's correct and half time it's not correct, which is kind of weird. But let's try to see if it's right or wrong. So CLF, which is our logistic regression, and we're going to say predict X test. And it gives us all of these different things. So it's basically saying that the first one is a cat, the second one is a dog, third one is a cat, and so on. Well, we need to first find out if it's a cat or not. We don't know. So you might go ahead and do something like this, text of 0. Well, that doesn't really tell us if it's a cat or not. It just, shows some sort of a numbers. So what can we do at this point? I mean, how do we even know if that's a cat or a dog? Looking at these numbers, it doesn't really tell us anything. So one thing you can do is we can try to use this array of numbers and try to show them not in a graph, but an actual image. And when we see an actual image, we will be able to find out that, oh, this is actually a cat or a dog. And one way to see these images is by using matplotlib, and matplotlib has a function called imshow, image show, and we can pass in something in there, x test of 0. And we may have to do like a reshape or something because it's expecting, let's actually do it like this, but I think it might say do the reshape. And we can also say that give us a gray one. I mean, give us a gray color. Apart from that, we'll say plt.show. Let's see if it does anything. Yeah, so it doesn't really like that we're passing in a single dimension. So we're going to go ahead and reshape it to 64 by 64. That's what we resize it to. Okay, so even though it's a little bit blurred image and all that, but we can definitely tell that, yeah, this is a cat. So it predicted correctly because the first one, it was telling us that that's a cat. So that's good. Let's check out the second one. Just changing the number to number 1 in the array would change that. Kind of hard to tell, but yes, I think that is a dog. So we can actually check that one off also.
Yep. And I'm sorry, can you explain the reshape again as to why we
Mhm.
have to reshape it?
Yes, so if we look at this plt.image show, let's see what it actually takes in. So image show takes in X array like image, whatever. And if we look over here on it basically works on a two-dimensional image, not a one-dimensional image. Or sorry,
Oh, we
two-dimensional
flattened it
array.
before.
Yeah,
It's because we flattened it. Okay.
because we flatten it. I think if we don't flatten it, then it may not work there because I think something else will actually not the train test split, but the fit algorithm might not work. It says, hey, you need to flatten it or something like that. But you can try it out, but that's why we are using reshape. Yeah. And we can also print out a couple of these images. Like if we just want to verify these 4 or 5 of them, actually most of them are cats in the front row, we should be able to display these things by running like some sort of a loop. So I can say for index in range 0 till 5, it's going to run 0, 1, 2, 3, 4. And we can go ahead and say plt.subplot. Subplot means that inside this plot, we're going to create another plot. And meaning us, inside the image or inside the plot area, we're going to create multiple plots, like smaller ones. And we're going to pass in, let's see, index position of the grid, arguments, number of rows, number of columns. Okay. So we can pass in over here, let's say 1 row, 5 columns, like the height, and then index +1. We're just going to make it a little bit move to the right-hand side after each plot. And now we can actually use our same approach. Instead of this 1, we can say index. And I don't think we want to see the axis, so we can say axis off. And I think that should be it. Okay, that looks actually much better. There we go. That's definitely, we can already see a bit of a problem, right? So cat, dog, cat, this is a dog, so this one is again wrong. 1, 2, 3, 4, so this one is coming out to be wrong. Then we have cat. Let's go ahead and make it like till 10. Oh, what happened? What do I do over here? 1 through 5. Oh, this is 1 through 5, 1 to 10. I think we have to do that. The problem is that now it's going to fit really badly if we do these things because it's trying to fit like 10 different things over here. So it's very hard to see, but I can already see that this is a dog, this is a cat, this is dog, cat, this is dog, cat. So it's definitely not a good training model that we have created. It's not able to detect correctly. Not sure how we can make it better. 65 by 65 is fine. What happens if we remove this flattened part of it? It might run all cells. It might complain somewhere that you may have to flatten it out. Let's see.
I do have a quick question.
Mhm.
Um, so I noticed like the images were really pixelated, and I'm not saying it has anything to do with the detection, but say for instance, we wanted to like actually test with high quality images, which I went through and the images are high quality,
Mhm.
but is it importing the images as like high def images?
Um, it is importing it like over here. It's importing the images. It does import it as grayscale, and then it resizes it. So maybe during the resizing process, that's where it's losing its, or in getting a little bit pixelated or getting like, a little weird.
Right.
But it is loading the actual images in the grayscale. I don't know if it messes up over here. Let's see. If I try to put this part a little bit over here, we may be able to display like one of them. So we get the image over here, and I wonder if this will work over here. Even though we're running it in a loop, if we say image, the problem is that this is just, I don't know why it's so slow. There are not really that many images.
It's slow for me too. So
Oh, slow for you. Okay.
it's not you or your machine.
Hmm. What is it printing out? It's not really printing out anything, I guess. Yeah. Yeah, it's not really printing out this part. But the images it's loading should be okay. And now you can see it's actually telling you found array with dimension 3 looking less than equal to 2. So that's why we were flattening it out somewhere over here, I think. There we go. But yeah, this is not going to work over here. Run all cells. Okay, let's see. And we can always ask ChatGPT, like if there's something wrong that we did, how can we improve it? So let's go to ChatGPT over here. And what I'm going to do is I'm going to just the model score is 0.52. How can we increase it? Maybe one of those things that we can do to increase it can be to use a different algorithm, some sort of algorithm that will allow us to do classification even better than this one. There we go. And let's see what it says. Feature engineering, model selection. Yeah, there we go. So it's actually telling you model selection, a lot of different things. But yeah, it can be anything. Maximum iteration, model selection, SVM, which is support vector machine, random forest, neural networks, like in deep learning. We can do all of those things to increase it. And usually, actually, these kind of problems, especially for the images, it's more of a deep learning problem rather than the logistic regression problem that we're doing. Because deep learning, you will have like different layers, and each layer will have neurons associated with some sort of the attribute of the image. Some might be intensity of a pixel or a color or something, and they will they will be arranged in a different way to extract out more features and to get to an actual point that we're looking for between cats and dogs. So whenever we're using images for classification, deep learning, which is, I guess the next course, is a much better approach or will be a better approach rather than using logistic regression that we're doing. So that can be one of those things. All right, let's see over here. All right, any questions regarding this part?
Nope, makes sense. Just have to review. I think the main issue with me is just remembering all the syntax, like remembering
Mhm.
all the libraries to import and like what methods to use from the imports. I get like exactly what you're doing, just hard to
Hmm.
remember all the imports.
Yeah, yeah, yeah. All right. Okay, let me see. We have GitHub. Mm. So on GitHub, you have those practice exercises, practice exercises 4A. This is for like K nearest neighbors, practice exercises 4B. Okay, that can be a little bit more what we're working on, but this is for logistic regression. It's using, and there are all the stuff. I mean, you can, try to do, obviously, it's like model to predict pricing, model to predict the income. Let's check out this data set. This is a real data set. This might be like too big, but let's check it out. I thought they had the data set in a CSV file. This is a CSV, but not really nicely organized. Okay, so probably we won't be able to use this one. Adult income data set. Um, let's see. All right. Create the data set as CSV for the following. Well, not download the data set, create a fake one. There we go. So it's creating something for you. The data set contained 1000 rows. I don't think so. More rows. Income level. If it's country natives, there's some user which work demographic employment along with their income level, whether it exceeds $50,000 or not. Oh, it is logistic regression. Okay. Let's see. Yeah, so we can just use this data set. I think their data set is missing all the column names for some reason. So this is just creating. And whenever we are working with these data sets with so many features, we have to first understand that what features matters and what features doesn't matter, right? So let me go ahead and create this data set. The last one is a little bit messed up, so I'm going to remove that. There we go. And save it. Adult income data set. And I'll send you this data set. You can check it out, and I'll update the assignment to use this data set. Maybe I forgot to name it as CSV, but once I think you download, you can name it as CSV. So this is the activity or the assignment. We don't really have that much time to even work on it this much, but let's see actually if we can do a little bit. So much windows open over here. Adult income data set. Let's change its name .csv. Okay. And I can move it into this folder. All right, let's see where this is. New notebook. All right. Pandas or import pandas as pd.read CSV adult income data set. Okay, it's appearing data frame and data frame.head There we go. Okay. You can see it's a pretty big data set. And I think this income level is the one column that we're trying to predict, which means that if the person income is over $50,000 or not. So looking through this data set, do you see some things, some columns that will not make any sense? Or is it all of these things are going to make sense to determine if the person income is over $50,000 or not? Let's see over here, adult, work class, private sector, age. Okay, age and income does have a relationship. Work class, private sector, or public sector. Education does have some effect on the income. It definitely does. Marital status. Now, does marital status have effect on the income or not? I don't know. Occupation is good. Relationship, race, sex, capital gain, capital loss. I'm not even sure what those things are. I mean, capital gain and capital loss are for obviously when you sell something and then you have a gain or loss for property or stocks, but income, I'm not sure what do you think? I mean, do you think these things do matter or not for the income?
Uh, I mean, I don't think in this context it does.
Hmm.
Specifically in this context, because you can have different capital gain and loss every year.
Yeah.
It's not like something that you can set to like something that's like more permanent. Like you
Hmm.
can have the same salary for a long time, or your salary is kind of set, but capital gain and loss is
Hmm.
it's more variable, I guess. I don't know.
Yeah. Yeah. I think it is because, as you said, that you can have, you know, sometimes you can have gain, loss, or nothing at all. And then we have hours per week. Hour per week, I guess how many hours a person is working. Does that have impact on the income level? Well, it can. I guess if you're paid hourly, then yes. Native country, probably not. I mean, if everybody is from United States and these things don't really matter that much, probably everyone will be in US from here. Let's see if I say tail. Yeah, everyone is from US anyways, so or most of them, I guess. So I don't think it matters that much. So we can remove these column, this column, this column. These do not really contribute. Race, does race contribute to more? I don't know. Maybe it does, maybe it doesn't. Does sex contribute to that? Again, that's the model that we can create, and maybe model can tell us more. So load the data set into pandas data frame and all that stuff. So check the missing values. Are there any missing values? Probably there is not. And then data processing for logistic regression, and then the training and all that stuff. So once you remove the columns, fill in the missing things, which I don't think there's anything missing, and then you can actually train the column using logistic regression and create the model that can find out that if these are the features, these features plus this one, will that based on these features, will that make the 50,000? I mean, will you make $50,000 or more income level one or zero, I guess. Um, and now, I mean, yesterday we also covered Flask, so you can even create the whole website where people can select these things. They can enter their age, They can select their work class or education, and then it will tell you that, oh, it's going to be, you know, your income based on the data that you provided, your income level is like 1 or 0. So what we did yesterday was more of a practical side of things, where you learn how to kind of like integrate it to a web app, which was kind of cool. All right. Any other questions?
Nope.
All right.
Straightforward.
I will update this. Let's see if I can update it really quickly so that you will have the updated data set. Let's see, where is it? This one. And sample project. This one. Probably move it over here. Okay. It was 4B, I think. So practice exercise 4B and income data set. That again, link was a little weird. I think it's called adult something. Adult income. There we go. And just to double check it. Okay. For income level. Okay, so it should be updated for you on the website over here. Yeah, there we go. It's much nicer data set. There we go. All right, so that is pretty much it for today. Tomorrow, we are going to look at a different algorithm, support vector algorithm. And again, once you create an instance of an algorithm, then it's always fit, predict, fit, predict. So all of them are kind of like same because scikit-learn has hidden all the complexities from us. But algorithms, as you have already seen, they do work differently and they have different score. So if you apply a wrong algorithm on the right data set, then your score or performance will be bad. All right. All right, then that is pretty much it for today. So I'll see you in class tomorrow.
All right. See you tomorrow. Thank you.
All right.